Hello. I noticed that it's really hard to find any teardown videos or pictures for this Stamos soldering power supply, and I thought we could fill that gap today. The device really deserves a video like that, to my mind. Yeah, in general, I've been really happy with the power supply. The build quality seems nice. All these buttons, they are pushable. You can have that beep on, but if you long press it, you can turn the beeps off. But still, you can probably, I don't know if you can hear the clicks. The rotary encoders are really nice. The same holds for these buttons. If you short press them, they don't do anything, but if you long press, then you can switch between the series and parallel modes. We have 3 channels altogether. The main channels are the first one and the second one, and then we have this additional always on channel, for which you can only select between 2.5, 3.3 or 5 volts, and you can't limit the current there. I think the maximum current is probably 3 amps for those, but for the main channels that's 5 amps per channel, and because you can go to the parallel mode, you can drive at most 10 amps, or then you can use the series mode when you get all the way to the 60 volts, because the voltage, maximum voltage for an individual channel is 30 volts. Yeah, it goes up to 31. One thing that may be a bit confusing with this power supply is the use of these channels in this series and parallel modes. Essentially, the control happens always using these knobs of the second channel, and then the wiring varies, of course, between the modes. Essentially, if we first go to the series mode, now we can turn it on, and we can measure 5 volts, and that's for the first channel. So if I hook it to the second channel, now we get the total of 10 volts, and so this is essentially our midpoint there. So this is the 5 volts for the second channel. Now if we go in parallel and we measure the current and turn it on, we can see that we get the total sum of the currents, and that works for both channels. Another thing related to use is that you can long press this current controller on the second channel, and it locks all these controls. So now you don't accidentally change anything there, and then you can release it by pressing it again. If I turn it on and I would like to adjust, for example, the voltage in here, I can just turn the knob, but now it's the resolution is 1 volt. If I long press, if I press it shortly, then I can switch the resolution. Again, I can go all the way to the tens of millivolts, or then we have 10 volt resolution. So it's really convenient to do those sweeps manually with this. You can set the appropriate resolution and sweep across that. That's really handy when you do some testing. But I think our main goal was to have a teardown, so let's open the device and have a look inside how it looks. I'm also really curious to see that. Yeah, this is really heavy. It weighs some 10.6 kilos, so you can really tell that it's a linear power supply, not the switch mode one. Yeah, the chassis is held by with these Phillips screws, which we have quite many. I think we have 10 screws in total. Let's open it. This one has a washer, but the other ones don't. And it seems that they've been screwed directly to the plate. So there's no real inserts for them. But of course, normally you are not supposed to open these devices like that. Again, that one had the washer, so it seems that they are on those bottom corners. And let's see what's inside. Okay, now we can see inside. First of all, of course, we can see this huge laminated transformer in the middle. It's not of those toroidal types, but a really beefy one. And then we have the cooling system. We have the fan in here that's temperature controlled, so it you can really tell when the system or the device is heating up. And then on the side we have these heat sinks, and those rectifiers are connected directly to that one. So we have the bridge rectifiers for all channels, and then we can see the relays and the smoothing caps over there. I can try to turn this to the other side so that we can see what's on the opposite side. Yeah, on this other side we can clearly see that there's one unconnected, probably a ground wire coming out from the transformer. But then attached to this fan-cooled heatsink we have those large series pass transistors for all channels, and there we have these separate heatsinks for those voltage regulators. So for this third channel we have a bit smaller. They've really paid some attention to these connectors, so they have some silicone glue on all of those wires. Here we can see some relays and these really large shunt resistors, and this mechanical switch, which is the main power switch. It goes to that circuit board, and behind the front panel here we have a couple of layers of PCBs. This upper PCB behind, I think that's for the displays, and then below that we have one for the controls. We have those buttons and knobs attached to that one, and then we have this main circuit. Here we can see all channels and their controls, and they all have their own 12 kilohertz crystals. And interestingly, we have these Corad ICs in here, which makes me wonder who's actually manufacturing this and designing these, because now it seems that this really resembles those Corad power supplies, and I can provide a link to that. In here we have the puzzler, and then this really wide cable connecting the ports together. I think that's all for today. I'm really happy to hear your thoughts and comments on how this Tamos soldering power supply is actually related to those Corad power supplies and to the other models of other manufacturers. And if you want more electronics videos, then please subscribe. Thank you. Bye bye.